Good day, everyone. I'm your maths teacher for today for those from the primary section. And today we'll be talking about decimal, specifically addition and subtraction of decimal. And someone may ask, what is decimal, or what is decimal about? If you can remember, when we had, or when you took your maths, say the module 1, module 2 of maths, talking about counting numbers and place value. There's a point in time where you came across a decimal point. And every other thing that happens, it works in this way. You came across, sorry please. You came across a decimal point, and every other thing became smaller. For example, you had your H, your 100, and your tens, and your units. And then when we put these points, and everything became smaller, it means it became a minute amount, a minuscule number, a small number, a fraction number. But the problem they deal with decimal number is that, or decimal as a whole, is that it doesn't really entail making it a hundreds or units. It means it works with the positioning. What do we mean? The positioning of a decimal point. Now, this is what you call your decimal point. So any number that comes after the decimal point is your decimal number. So, take for example, we have something like this, 3.23. In this case, we have two different kinds of numbers there. Two different kinds. The first number, which is when we're talking about your place value under this area, they are all capital letter, they are all caps lock. You can see all of them are capital letter, means they are larger numbers. But when it came this way after the decimal point, they all became small alphabetical letters, which means they are smaller numbers. In this case, your 3 is what we refer to as your whole number. I will just represent it as WN. Your whole number means it's full. It doesn't have any fractions. There's no remover in its system. It is a full number. Meanwhile, anything that comes after your decimal point, which is here, let me call it your DP, your decimal point. Anything that comes after it, it's your decimal number. Relatively to, this function also works for fraction, which is like a relative to decimal. Here's the catch. In fraction, it changes. For example, this number that is like this, now for example, can be something, let's just put it this way, 2 over 3. 3 whole number, 2 over 3, for example. Now, you will notice that this is your whole number the same way. But instead of a decimal number, because you have not converted or you don't have it in your decimal, instead of a decimal, you will have this to become your fraction number. Let's call it Fn. Your fraction number. So you can see the difference between the decimal and the fraction and the whole number. Now, subsequently, as we go on with the class, we're going to be seeing about conversion. Now, conversion of decimal to fraction and fraction to decimal. But let's come back again. So we have established that your decimal number, is any number. Let's define it properly. Your decimal number is any number that comes after the decimal points. And this is the decimal points. It's represented by a dot or a period. So before the decimal point, it is not a decimal number. But after the decimal point, now that's a decimal number. Now, take for example, let's do some, so I see you're having a number like this, 0.0029. And someone is asking you, what's the decimal number in this? Your decimal number is basically every number that comes after the decimal point, which is your 0029. Now, the 0 point can be put there just for emphasis sake. That's why you hear sometimes some people, you might have gotten this one way or the other, so people just skip the other 0, this 0, yeah, this whole number, because it's 0. And 0 is nothingness. 0 is a vacuum, is nothing. Anything times 0, anything that goes with 0 will become nothing, because anything that 0 absorbs, even if it's 1 billion, 1 million, they become nothing. So some people just keep the 0 and just use 0.0029. Why? Because they are interested in the case, or interested in the numbers, the series of numbers that comes after the decimal point. Now, but in this case, now we are going, that's an introduction to it. We are going to see about the addition. So we are specific on this topic right now. While we're dealing on decimal, we are dealing with a subtopic that says addition and subtraction of decimal points, of decimal numbers, of decimal, let me put it of decimal. So let's see the addition. Let's start with the addition. Addition of decimal. If you have a number, a case whereby they brought a number like this, 60.39 plus 38.14. Note this very well. I'm going to go with step by step. I will do some illustration and demonstration here. Now, I teach in a way that you must understand the movements or the pattern of the numbers, the pattern the numbers takes. Now, notice that this 60 here and this 30 here are both coming before the decimal points. Before the decimal points. It makes them both whole numbers. The both of them are whole numbers. What do I mean? You can remove the both of them first and keep it this way. In case you will not understand how to do, I will still do the other method you're familiar with. But let me start with this way, the simpler way. I call it the break it up method. You break it up, you take the whole numbers one side, and you take the decimal numbers the other side. So you have here 38 plus 60 plus 38 rather. Now take the numbers that comes after the decimal point we have established. Those are our decimal number. Decimal number is any number that comes after the decimal point. Those numbers that come after the decimal point, those are our decimal numbers. So we'll take them one side. We can put them here. 39 plus 14. We add up. Let's start with the decimal number. When we do 9 plus 4, we have 9. We want to add another 4. So we go 10, because we're starting from 9. 9, 10, 11, 12, and 13. So when 9 is added to 4, the number 13 is gotten. But we all know in arithmetics, you don't write 13 because you have other components to work with. So you write down the 3, you move up the 1 to add to this group over here, these components over here, which is 3 and 1. The items are 3 and 1. So when you add 1 plus 3 and plus 1, you have 5. So you're having 3, you add 1 again, that's 4. You add another one again, that's 5. So you're having 5, that's 53. Coming this way, then this is our decimal number. You can just specify it to just get the knowledge of it. Coming this way now, we know this is our whole number from the get-go, from this place where we extracted the question or where we broke it up. Now 0 plus 8, we have 8. 6, because again, Anybody that adds with 0. 0 is quite a tricky number, a funny number. Any guy that add with him will become that person. Anybody that subtract with him will become that person. Anybody that times with it will become 0 because he absorbs. Anybody that divides with him will become 0 because he absorbs. So it's a very, very interesting number to play with. So 0 plus 8 is 8. 6 plus 3 is 9. Thus, we have 98 and we have 53. But we know that 98 is our whole number. And 53 is our decimal number. The only thing that differentiates a whole number from a decimal number is our decimal point. We've established that. Therefore, your answer will become 98.53. Pardon me. 98.53 is your final answer. Now, you may think this is a long procedure. You're correct. It's a long procedure. It's just a way for you to understand it and get a hold of it at first. And when you master this, the next step or the next method will be simpler for you, which is the straightforward addition of decimal numbers. Now, the next step is to use the 60. So we have the 60.39 adding with the 38.14 or 0.14. You straight away add everything up. 9 plus 4 we have established is 13. So you write down the 3. You carry the 1. You plus with the 3. 1 plus 3 will give you 4. 4 plus 1 will give you 5. So you have the 5 here. Now because you have the points, you put back your decimal points. Then you do the 0 plus 8. The 0 plus 8 will give you 8. We say anybody that plus with 0 will become that same number. Because 0 is nothing. 6 plus 3 will give you 9. You've gotten the answer. You can tally it or you can check it with the previous answer. They are the same thing. But here's the catch. There are times whereby you are trying to work with decimal points and there are some trickiness in it. It's kind of feel like a tricky position at that dispensation. It's important that you understand where the whole number falls in and where the decimal number falls in. What do I mean? For example, you're given a question 3.49 plus what is 0.0. Let me call this slow. Let me put 13.49 plus 0.038. Your mind will go straight away to matching numbers, to match all the numbers, because there are 4 numbers here, 4 digits over here, and there are 4 digits over here. You may want to do this. 13.49 plus 0.038. At this position is a failure. Because you are having the decimal points being moved in different places. One of the decimal points is coming after a single digit, which is also a 0, an empty vessel. The other number is coming after a double digit, which is also a tens. From our place value is a tens and a unit. There's a tens and a unit there. It's coming after. So there are 2 digits there. And if you do it this way, you will run into a loop, an error, and you keep going in a circle because it's not going to work well. The right way of doing this mathematics is to place, you solve or you place your values from right to left. From right to left. And when we talk about left, your left must come, everybody that comes after the decimal points will be in the right hand side, right? Everybody that comes after the decimal points will be in the left hand side. What do I mean? You place it this way: your 9, your 4, your points, your 3, and your 1. For the purpose of not making a mistake, put your second point, decimal point here, so you will not make a mistake. You must make sure that the 2 decimal points tally, they are in the same line. They are in the same line. Then you can put the numbers that come before the decimal point, starting with the 8, the 3, the 0, and then you put the one that comes before the decimal point, 0. Now, in this way, you've made your life easier. You can get the right answer. Why is this one? If I will do this math for you, which is an error, if I will do this math, you'll see what the answer is going to give to me. This will give me 7. I take 1 over here because this is 17. 9. I add 8 to 9. I have 9 already. Let me add another 8. 10, 11, 12, 13, 14, 15, 16, 17. This is 8. A full hand is 10. I have 8 here so far because excluding 2. And the 8 plus 9, or the 9 plus 8 rather, gave me 17. So I write down the 7 because it is a double digit number. I take out the 1 in front. 1 plus. So I do 1 plus 4 is 5. Now 5 plus 3, you can count it with your hand again. 5, 6, 7, and 8. This is 3 now so far. 8. So I write down the 8. Now here's the problem. How do you now add a decimal point to a 0? That's the error. So you find that you're finding yourself in a group where remember you're putting something like a 0 point or whatever, and you're putting here a 3 point or whatever, and you're putting 1. How can it work? It is impossible. It's not feasible. It's not logical. It's not a mathematical signage or way of doing mathematics or solving mathematics. Now this is the right way. You'll find out that you will not have all these problems you're having here, over here. What's the answer now? Let's assume, now for the purpose of balancing, because there are 3 digits that comes after the decimal point, 3 digits. That means, because this one is having only 2 digits after the decimal point, we can still just add a 0 just to fulfill all righteousness, to make it easier for you to understand. Because if I just do and bring down 8 here, you think, how did you bring down the 8? What happened? What procedure, what method did you use to bring down the 8? So let me just add the 0. Because again, I said, a 0 is a nothing number, it's empty. It's a vacuum. It's a hollow number, it's a void, it's nothing is there. 0 is 0. And anything that adds with 0 or anything add with empty space, which is what this empty space is here. The empty space is also 0. So if I add the 8 to the empty space, it's still 8. If I still put the 0 to fulfill righteousness, to make it 3 digits up here, it will still give me the exact same thing. So I'll bring down my 8 here. Now 9 plus 3 is interesting. I have 9, I count 3. 9, 10, 11, 12. This is my 3. 9, 10, 11, 12. So I have 12 here. I lift up a 1. So 1 plus 4 now will give me 5. 5 plus 0 will be 5. I put back my dot, my decimal point, because decimal point plus decimal point is decimal point. So 3 plus 0 will be 3. Again, to fulfill our righteousness, if you feel like you want to balance it, you can still put another 0 here to make it 2 digits so you can balance it. I don't need to do it, but if you want to do it, you can just do it just to make sure you understand how the movement is. And now you see that 1 will now come down, and this is your final answer. It's important we follow the method correctly. I've seen people go through it the wrong way, this way, the 40 method, and they are caught in a loop whereby they are thinking for a long hour, especially you that is going for an external examination. You're going for an examination and you're just stuck there on that one question. You're thinking, what could be the answer? You're looking at even the options. The option is not even giving you that kind of answer. This is not a feasible kind of answer. We're having double decimal points being reflected. It is not logical from mathematical standpoint. So you must know how to place your values or place your numbers. Hence why you need to learn the place value. Just get it at the tip, your fingertip, so you can do it or apply it easily. So that's that for the addition of decimal number. Now let's run through subtraction. Again, I will use similar method, similar numbers to also buttress my point or to break down the points I want to make on the aspect of subtraction. Subtraction of decimal. So you can call this 2.0, you can call this 1.0. Now, subtraction of decimal. Now, we're all familiar with our respective board mass, or at least we should be familiar with our respective board mass. Subtraction is all about removal. Removal is the difference between, when you're comparing two things, difference between one thing from the other thing, one component from the other component, one item from the other item. The difference is subtraction. For example, I have a pen like this that shines, colors here are white and black for the most part. Now here's the catch between, or here's where subtraction comes in. When I remove the labeling around the white spot, and I see a gray color, or as we love to call it in this part, an ash color, that means I have subtracted something. My own will not look like the ones owned by other people. Mine is going to look different because there's a subtraction, there's a difference, a removal. I have removed something from it. On the other hand, while it is white like this, if I come, I bring another ink or I bring another color, I paint it, for example, a blue, I now have a different texture. I have added something I want. Maybe I do not like the white that much. I want a blue. I added the blue. I have added something. Hence, addition. So subtraction is taking away. Addition is bringing together. Now, we usually use a word, a semantic word for subtraction, addition. Addition, we call it plus, but one for a subtraction now, you call it minus. Now, let's say we are working with this same number over here, for example. Again, the same analogy. Any number that comes after, before and after. Before whole number, after decimal number. We're working with this number. Example. They say, do 60.39 minus 38.14. This is a very, if you understand the way addition are moved, don't joke with that of subtraction, because subtraction is quite tricky. You must place the values correctly, and you must move the values rightly in order to get the right answer. Now, let's work with what you did here initially. Break it up. Let's use the break it up method. I break it up. All the whole numbers one side, and all the decimal numbers the other side. Let me work with the decimal number first. 9 minus 3. 9 minus 4 rather. You're having 9. Let me use my finger. You're having 9. And I want to minus 4 out of the 9. So 9, 8, 7, 6, 5. This is 4 I've counted so far. So 5 is remaining. Thus 9 minus 4 gives you 5. Now say you're having 3 minus 1. I have 3 and I only want to remove 1. Just one number. 3 minus 1 is 2. So you have 2 now. Your answer there so far is 25. On the other hand, by the way, this is for the decimal number. For the whole number rather. 0 minus 8. Here's the trick. Like I said, move it rightly. Move it rightly. Don't make mistakes. 0 minus 8 is not a feasible number. It's a negative number. It's not a positive number. It's a negative number. Because 0 cannot minus 8 and you have a positive number, you have to borrow. You have to ask somebody to lend you something. So 0 is going to ask 6. 6, please, can you give me one of your strengths, one of your power? Let me use and fight 8. And when you borrow 1 from 6 to 10, or rather to 0 rather, you get 10. So our good friend here becomes 10 when this one becomes 5. Thus, this becomes 10 minus 8. Now 10 is bigger than 8. It it can work very well, and it can give you a positive number. So 10 minus 8 now, we have 10, we want to remove 8. Stay with me, let's go. 9, 8, let's go. 1, 2, 3, 4, 5, 6, 7, 8. We've removed 8. What is remaining in our hands now is 2. So 10 minus 8 is 2. And then we have 5 remaining. We have 5. We want to remove 3. Let's go. 1, 2, 3. 2 also. So 5 minus 3 is 2. So you will notice that in our whole number we have 22. In our decimal number we have 25, giving us an answer that says 22.25 as our answer. That's using the break it up method, which I developed myself, my own self. Now let's try using the one we are familiar with, the basic arithmetic method, which is straight, just subtracting straight from the question. Now you're given 60.39 minus 38.14. Again, the same procedure. 9 minus 4, we agreed is 5. 3 minus 1, we agreed is 2. Bring down decimal point will come down. 0 minus 8, we agree it's not feasible, it's not logical. So 0 borrows 1 from 6. And 0 becomes 10, 6 becomes 5. 10 minus 8, which is bigger. 10 will give you, minus 8 will give you 2. 5 minus 3 will give you 2. Hence, your answer is 22.25. You check it, or you check for your proof to check if the numbers correlate with what you have broken up, and the answer is similar. Now, you must understand that there are cases where the subtraction theory or the subtraction method or the subtraction topic will be very tricky. You must understand the placing of the values, hence place values. You must understand how to place it correctly. One little fault and you have a faulty answer. But put it rightly and you have the right answer. Now let's see the second example I used there when I did with multiple numbers after the decimal points. Let's say we have example 2, we have 13.49 minus 0.038. Now you want to place it correctly. Again, like I said, in subtraction, attention to detail, very, very important. Now you have 13.49 minus 0.038. You must put it correctly. Put your 13.49. Start again, like I said, I'm just writing it this way. You can start from the right to the left. 13.49. You now put your minus sign, and then notice where the decimal point is up. Just align the decimal point in the first value you're using against the next one. You must make sure they are all in the same line. You align it in the same line. So put your decimal point back first. Then now you can work with the values left and right of you. Start with the left. You put your 8 here, you put your 3 here, and you put your 0 here. And then you put your 0 from the right here. Now, initially or previously, when we were dealing with the addition, I told you the importance of adding a 0 if you want to add. The importance comes here. Is this the point? That 0 is needed. Why? Because there's an 8 here. Somebody has to work with this 8. So, logically or just through your out of the box thinking, just add a 0 at the end of this 9. So you can make here 3 digits after the decimal point against 3 digits after the decimal point here. 0 minus 8, we are agreed that it will not work. So 0 will borrow 1 from 9, and 9 will become 8. Why 0 will be empowered to become 10. Now you do 10 minus 8, and you have 2. 8 minus 3. Now, 8 minus 3, that means you have to count 8 then remove or take away 3. We have 1, 2, 3, 4, 5, 6, 7, and 8. So these are 8. We have to remove 3 now. 1, 2, 3. We are now left with 5. 8 minus 3 becomes 5. Earlier on we said already, anything that minus with 0 will become that same number, because 0 is a nothing number. It's not a number that is feasible. So 4 minus 0 will become 4. You bring down your decimal points. 3 minus 0 will become 3. Again, if you wish, as in the case here, where we added the 0, you can wish to add another 0 just to correspond the number. Call it corresponding number. So we correspond. For example, if there are 5 digits up here, you want to correspond and make sure that there are 5 digits down here. So you can just put a 0, it's like 0, 0, just to help you, if you wish. But in my own case, I just assume that God is a blank space. I just bring down the 1. So 1 minus blank space, which is still 0, will become 1. Thus, this is my answer. This is all about addition and subtraction of decimal. Now, in subsequent time, we're going to learn more about decimal points as it translates to fraction, and even subsequent will become percentage. But I'll leave you with one last example from our question from our guide. So let's get a question from our guide. Now I'm getting a number here from 2018. There's a question in the 2018. There's a question they asked us here, and this is what will lead us to the next topic when we come next time. They ask about conversion. Convert 0.025 to decimal fraction. Now I told you earlier on when I stated it here, decimal fraction is any number or any mathematical workable number that can be moved from decimal to fraction, hence the word decimal fraction. If you can move a word or a solution, a mathematical problem from decimal points to fraction, you've corrected the way or the work for decimal fraction. Now, they asked us the question, convert 0, this is what we'll start from next week or next time. They say convert 0.025 to decimal fraction. Decimal fraction. Now, when I put PQ, you just know it's past question. Now, if you ask a question like this, the first thing you must notice or you must pay attention to is this, the number, the digits. You've noticed the digits is in decimal, so it's already in decimal. So that is to convert it to fraction. I'll give you an easier way. I will continue in that way next class, and I'll give you 2 other methods to use while you're solving decimal fraction or decimal numbers. Now, if you're given 0.025, we want to eliminate the decimal. The easiest way I learned in my own book, and it will help you. It may seem longer or it may seem shorter for you. It depends on your pattern of doing or solving maths, a problem. 0 points. Now I want to eliminate the decimal points. Thus, watch what I will do. For every one I count, I add a 10 under. What do I mean? I move this, let me put it here. When I move 1, there will always be 1. Every one movement is a 0 added to that one. I will explain further. I add a 0. I move the decimal point again. I add a 0. I move the decimal point and throw it away. Eliminate it completely. I add one last 0. Now, the only thing you will keep on up top is your significant numbers. 0, like you said, is a nothing number. It's insignificant. It doesn't make any sense. It doesn't add any value to anybody's life. It's insignificant. Your significant number starts from 2, and you only have 2 significant numbers there, which is your 2 and your 5, your 25. So you put back your 25. Thus, this is your decimal fraction. Let's say you want to go further. You want to think it, or you want to take it up a notch. You want to take it further. Now, notice this. Let me do it slowly. When I moved 1, it becomes something like this. 0.25 all over 10. The second method. I move second, it becomes 2.5 all over 10 times 10. I can just put 100, but I want you to understand why I'm doing that. 10 times 10. This one is like 10 times 1. Then I move to eliminate it, it becomes 25 all over 10 times 10 times 10. Hence, because the presence of 3 zeros in the tens, look at the 10, look at the 10, look at the 10, take the 3 zeros out, keep the 1, keep 1, take the 3 zeros and attach it to that 1, and you get your answer. That's the easier way of doing multiplication with speed. If you don't want to be slow, understand that there's a number, I call it my own self, I personally call it a fine numbers. Fine numbers, in my own term, is any number that ends with a 0. Because you can just take out the zeros and your life becomes easier. You only need to deal with the numbers in front of the zeros. So for example, if you're having 20 times 30, take out the 2 zeros and keep them one side. Work on the 2 times 3. 2 times 3 will give you 6. Add the 2 zeros back and you get 600. Easier way of doing your maths. If you want to save your time, but if you want to go through the process, you can put it 20 times 30 and it will take a long time and your time will be up and they'll say pence up. Now, if you want to do it, just take the zeros, put back at 25, take the zeros, 1, 2, 3 zeros. I put back my 1 and I add the 3 zeros back. 1, 2, 3. Can you see that my answer is similar to the answer over here? But in mathematics, you don't leave your answer this way. Now, it's not mathematically proven, or it's not correct if you do it this way. Mathematics, you must break it down to the lowest form, or the simplest form. Now, in this case, we're having 25 over 1,000. We will divide, breaking it down. 5 into 25 will give us 5. 5 into 10, let's use the 10 here first. 5 into 10 will give us 2. Into the next, this 0 will give us 0. Into this last 0 will give us 0. So we have 200. We use 5 again because 5 can still go. 5 into 5 will give us 1. 5 now into 2. 2 is too small. So you add the 0, the next 0. 5 into 20 will give us 4. 5 into 0 will give us 0. Thus, your final answer is equal to 1 all over 40. You've converted this number to this number and then gotten an answer that's feasible.